everyone. Great to be here. There's not much of a crowd, so hopefully the other talks are like totally awesome, or I don't know. But hope you get something out of this one as well. All right, so topic of today is I'm going to talk a little bit what is Rovio and how do we use data, and then I'm going to talk a little bit on why do we need streaming, and also tell you a little bit on the use cases that we use streaming for, and then I'll end up with some of tips or tricks or learnings, whatever you call them, like what we have to have built around Flink to support running our use cases in production. But before I start fully, I want to mention that we actually got a little bit EU funding in the form of this Streamline project. It's a Horizon 2020 project, so every EU citizen sitting in the audience kind of contributed into this, so thank you. And also want to use this opportunity to advertise. We are constantly looking for new talent, and yeah, this is a typical coffee break in Finland. Okay, so what is Rovio? So we position ourselves as a games-first entertainment company, and our mission is to set the world on fire by crafting the best games and entertainment in the world. So I think Rovio is best known from the Angry Bird brand, so the games and the movie. And our main headquarters is in Finland. So we just reached, or actually it was in the last year's autumn, we reached 4 billion total downloads of Rovio games. So that will give you some scale on the amount of kind of users that we have. We have 400 Rovians, roughly, and from that 400, I would say that something like a little over 20 you could call as a data experts. So we have two teams, data engineering, my team, and then we have a games BI team. Basically the idea is that these two teams kind of help other teams. So data engineering teams basically doing this kind of data engineering, like getting the data in such a format that then games BI team can basically produce valuable insights of that data to our teams, like the game teams, and then ads, user acquisition, you name it. So how do we use data? So this is like really simplified scenario, but before we really start a game project, we take a look at the market data. Okay, what kind of a game we should make? Are there any trending genres, sub-genres that we should invest in? And then once we have a game, for example, a soft launch, we use data to do profitable user acquisition. So we need to get the players in. And then now you've heard the terms like games as a service and live operations. So nowadays when you have a live game out there, it's basically not done. So we are constantly rolling out new content, new features, and then we are using, for example, A/B testing to optimize that, so make the game better. This is then the pipeline that we have. So basically what we have here in the left-hand side. So we have our game clients, and then our services. We have a data collection API where this client and services can send the data in. We store the data into Kafka, and then we basically have two different distinct pipelines, if you will. So one is kind of purely batch. So we use a tool called Secure to basically save the data into S3, and then from that data we have a data conversion process where we create these kind of columnar efficient data sets for teams to kind of query with tools like Presto and Athena, but also Spark or even Flink. So then we also have this kind of really legacy system still in place where we basically aggregate the data in Hive on daily level, and then we store that data into Amazon Redshift, and there we then calculate this kind of for example, where did this player come from and how much money did they spend on during the day, how many ads did they see. This is done in Redshift, and then we basically just export that out and create a columnar data set out of it, and then that is then also available. You can, for example, join the data analyst in the game teams and can, for example, take a level funnel from the game and then join that information with the actual user origin information. So that's pretty neat. And then I'm going to talk more about the real-time side of things, so I'll skip that for now. So when we use AZABAN Workflow Manager to do the managing the jobs and workflows that we have. Yes, so then how does then our other teams basically access the data? Not those data-oriented people, but like other teams, kind of product managers, developers, how do they access it? So one of the key, or basically the entry point for that data is a tool we call Pecan. So it's a cloud service for that all of the Rovio games are integrating, and it provides services like analytics, A/B testing, payment gateway, and ads. And one of the things I want to highlight is the personalization piece. So, for example, what that means. So, for example, we had a case where we were doing churn prediction, so trying to predict the likelihood of the player to stop playing our games, and then we use that churn score to force or show more interstitials, cross-promo interstitials or cross-promotion ads instead of network ads for this player, because we were thinking that, okay, this player is going to leave, but let's try to get him into some other Rovio game. So we run this, and what we actually were able to see is that 27% more cross-promo users were received into the target game, but then the source game was, or retention numbers of the source game was hardly affected at all. So that was a really nice result, and good example how we can basically, through the personalization, affect the game Rovio portfolio performance, and also trying to do it in such a way that it's not really nasty for the end user. So we still want that the games are kind of fair for everyone. Okay, so if we have all this in place, so why would we need streaming? So if you think about our reporting or like games business reporting, it's mostly like daily base. How many purchases did this person? How many purchases did this person make? How much money? How many ads impressions we did have? We calculate the DAU. How many players do we get into the game? We calculate the retention numbers like D1, D7, D30. It's basically daily base. So why do we need streaming? So easy answer is time to data. So if you just think about this kind of traditional reporting system, like game teams come in to Rovio in the morning, and then they want to get the data of yesterday. And for this batch process that we are running, we are basically like processing one day of full data. It's not quick operation. And so we are basically running in the limits of the system all the time. So we are ready in the morning, but you know, if you are running stuff on EMR, it's not. It does have hiccups. It doesn't have very good SLA, to be honest. So if there ever is a hiccup, we are always late in the mornings. So even for that, it would be great to have a system that incrementally kind of processes the data during the day. And then the other piece of this is basically the world is moving more and more towards these, what do you call them, like automated systems. So, for example, in ads, real-time bidding is a thing nowadays. So basically, when there is a when you play some mobile game, for example, and there is like, okay, now there is a place for showing an ad. So real-time bidding is actually such that advertisers are asked kind of like in real time that, hey, how much would you pay to show an ad for this user at this specific point? So when you kind of start optimizing those things, like in doing automatic decision making, then one day kind of late or lag in the data is just not enough. So that gets then into the, okay, what have we been doing? So one of the kind of this was basically, I would say the very first thing that we did was basically monitoring the data or monitoring our systems in real time. So when we were launching a new game, for example, if before we had any kind of real-time monitoring, it could be that we broke something and we noticed it then after one day that, hey, why for this game version we for example, suddenly our like session lengths drop quite dramatically, that there must be some sort of crash in place. So what we kind of did was that we basically you were able to build the Flink kind of a, we had this specific, before Flink had the SQL, we basically have this specific like definition JSON file that you could define to define these aggregation rules, and then that would write like data into InfluxDB, this time series data, and then we used Grafana dashboard to look into what's going on, or you could monitor, okay, how does, for example, our ads impressions work in this version of the game. So it has now evolved, like Flink now has this Flink SQL support, so we basically use that. So you can define with Flink SQL these kind of aggregation rules, how you produce the time series data. We store it into the InfluxDB, and not only we use our Grafana dashboard to monitor that data, but we also have a anomaly detection in place. So we are actually using just open source tools. I don't know if you have used, for example, this Prophet. It's actually quite nice. So if we notice an anomaly, we basically have a system in Nagios that, okay, notice the anomaly, and then we send a notification into the PagerDuty that then wakes up the cloud operations engineer 24/7 that, hey, something is wrong in the system. And why the Jupyter is there? So when some incidents happen in Rovio, we used to do this kind of incident notes, like manually. And this is like really forward-leaning. I don't know if we are really going to do it, but my idea was that, hey, when we have the incident, what if we could actually generate this incident node like automatically? So there can be millions of different, or let's say hundreds, thousands of different time series data, but you can find then using Prophet this, okay, correlations with this. So what if we could actually form this kind of incident node that, okay, in-app purchases declined because this service went down, and we could actually automatically create this nice anomaly report or incident report. And this is just how the Grafana dashboard look like. So this is, for example, how we track the ad impressions in our games. Then the other one is this personalization. So we have again this kind of a own JSON configuration that you can use to, and that's kind of ingested by Flink to kind of set some attributes for the player. For example, one team could, for example, track when player reaches a certain level in the game and flag that in the player profile, and then give some premium content for the player or premium offers for that player. We now have this JSON in place, and it doesn't really support nice kind of window aggregations and whatnot. So we are actually planning, maybe we start using Flink SQL in this one as well, because it looks quite handy. Then one key thing, this is actually a big thing in Rovio, so integration with third-party systems. So traditionally, if you add some third-party in Rovio, or in mobile game, they have an SDK and you integrate that into your game client, and then you kind of then basically the client starts sending data into that third party. So that's not really flexible. So for example, if we want to get rid of that third party or legislation changes, then to get rid of that client, you need to do a client-side update, and that's really expensive. So what we are actually nowadays doing, we integrate with third parties through server-to-server connections. So for example, Singular, it's an attribution provider. It's really key in Rovio. So it basically tells us when we are showing ads in other games or other places, they basically tell us that we send them data on install, and then they tell us that, okay, this guy came from Facebook, from this campaign, and even that from a game of this, or from this game. Normally they don't tell you the game, but just with this kind of anonymized ID. But anyway, so what we actually do, we have a Flink stream. We basically just filter the data, but we also, because we want this to work on also the games that we don't do any client-side update. So it might be that you don't get all the data in one event type. So we basically are doing windowing to ensure that we have all the data available, and then we send the data into the third-party system. And we are using, for example, because the system that we are sending the data, so we are using Async.io, so we can actually parallelize the request to the backend without kind of adding huge amount of concurrency or the parallelism in the actual Flink stream. And then also, this is kind of a system that is kind of complementing or helping our batch process to be quicker. So for the GDPR, I don't know how many of you know about it, but I suppose many of the data people have been working with the GDPR lately. But what we basically are doing there is that we have our data set. If you look at the left-hand side, this is how our data looks like. We have so different identifiers. So we added this kind of extra layer of pseudonymization of the data for long-term storage. So we have all those identifiers in single event. And what we are then doing in Flink, that we first just use like a flat map to make like a tuple of event type. ID type and the actual ID, and then we just have a distinct reducer with 1 day window and key by the application ID, which is the game, and then the ID type and the ID, and then we just store this data in S3 using bucketing sync so that it's easier for the downstream kind of systems to process. So this way we have rather than kind of doing this as a batch process in the end of the day, we are basically constantly doing it. So the data, if everything is fine, should be available in the morning when we basically, or in the midnight when we are basically starting to reprocess the batch process starts processing the previous day's data. So, and in the future, this is maybe, so we are currently concepting in the solution where we are basically trying to replace the whole legacy system that we have, and the idea would be that we use streaming as much as possible. Got very good ideas here as well how to do that. Actually, I like the client SQL client thing quite a lot. It actually does quite much what we were kind of coded ourselves. So let's see. Also the model, like we are also planning to do something on the modeling side of things. So currently our kind of modeling is batch, and we are basically doing also the scoring, or we do the fitting in batch and also the scoring. So we are on daily basis running different scoring jobs, and then we store this information per player into some profile field, but it's not enough. So we basically want to be able to apply the models in real time. So that's something we are working on as well. Right. So what do we need then to run streaming in production pipeline? So here is some kind of we've used Flink now over 3 years, so there is some historical baggage, or some things have been already kind of introduced in Flink, or are kind of part of core Flink. But I try to gather some things that are still not yet maybe there. So, but what we on high level what we need. So we need the data. So we had those 4 billion downloads. So if we want to, for example, include or calculate in streaming the some statistic based on the user cohort, meaning the registration date and the user origin, we basically would need to have that information in a state or somewhere that we can actually enrich that event with that information. So we need basically to backfill and have that, or initialize the state with all those players that we have. Then we also need SLA. So our system should, like, more and more we go into the streaming, and for example now we have this third-party integration with the attribution provider, so system just need to operate 24/7. So that is the reason why the system that we deploy needs to be somehow easily maintainable by our cloud operations team. And then also the CI is important. So we are doing constant updates. So it's important that the deployments are carefree, that we don't introduce soon like a big breaking bug that then like destroys the whole system. So that's on high level what we need. And so how do we in Rovio operate and monitor the Flink streams that we have? So we had there were quite at least a few sessions that I was in were talking about how a kind of a Flink, like you dynamically reconfigure the stream without actually restarting the actual Flink stream at all. So compared to that, we are really old school in Rovio. So we basically just have the Flink streams, or the SQL thing I was talking about. It's basically in GitHub, and then we use TeamCity, or like to build the system and deploy the stuff into different environments. Smoke is our test environment, Mist is our staging environment, and Cloud is our production environment. So, and what TeamCity is basically just doing, it's just making Uber charts and storing them to S3 in some specific location. And when we then the runtime side, so how do we actually run it in Amazon? So we are running Flink on EMR and on Yarn. So, and what we basically just do in bootstrap actions, we set up Flink, set up some logging configurations and monitoring, and then we have implemented some tools ourselves to, it's mostly for this state handling. I will talk a little bit more about those later. And then we also are using AZABAN workflow manager to manage these Flink jobs as well. So starting the jobs and stopping the jobs and monitoring them. Excuse me. And then on the right-hand side, some monitoring tools and systems that we use. So Kafka offset monitor, it's actually a free tool, really recommend it, actually been really handy. We use that to monitor the offset, the consumer offset lag. And then in Grafana, I told you about those we have those time series data, for example, for our analytics event, but we also have our service information there, like like CPU usage and I/O, whatever. So we have that data in InfluxDB as well, so we can monitor that as well. And then for logs, we are using Kibana. So there here actually are listed few of the tools that we are kind of or you need, which modules you need to deploy into the EMR cluster, ability to use both Kibana and Grafana or InfluxDB. And then we, for this kind of Nagios we basically just use to monitor these systems, like do the automatic alerting and whatnot, and that's also integrated into this PagerDuty I mentioned earlier. And yeah, we are running the same anomaly detection as well, what I mentioned earlier. So, and if you like, I added this slide like today because there was a lot of like at least few companies showed that they have implemented the front end to deploy jobs and whatnot. So we haven't implemented really anything. We have implemented this specific plugin for AZABAN. So AZABAN is this kind of workflow management tool. You should check it out. It's similar to Airflow. And so why we use AZABAN? So we've used to it. So we use it for batch. So we wanted to use the same system to orchestrate the workflows as we would use for batch processes as well, because it's not my team who is actually operating this 24/7. So it's actually our cloud operations team, and they are the ones who wake up 3 a.m. if something is wrong. So they rather have only like few tools that they actually need to use to kind of fix problems in the middle of the night. Okay, and then quickly, how do we actually bootstrap to EMR cluster? So actually nowadays, if you are okay of not running maybe the newest version of Flink and can use the default version that is provided, it's actually out of the box for provided in EMR, so you don't necessarily need to do anything. But if you want to do it yourself, because we want to use like bleeding edge version and sometimes even build our own, like from the for example the latest version snapshot. That so it's really easy. I was lazy. I didn't want to. I didn't remove the. So this is basically the script that we're using. So there's a lot of it extra stuff. But if you read this, you can see that it's actually nothing more than ensure that you extract the Flink package into some specific folder in the master node. So it's really simple. And this also, there's like just headers, but it's like install the Telegraph and FileBeat. Those are required for the InfluxDB, Grafana and the Elk stack integration. Okay, so this one is actually something that I discussed in the Flink user group. So Flink doesn't currently have a default functionality to actually start from a latest restore point. So if you are doing checkpoints and save points and you want to start, we wanted our system to, if you don't define anything, we wanted our system to automatically start from the latest one. So this, what we, I was not able to sell this idea in the Flink user group, but well, let's see. So, but it's quite easy. What we are basically doing in that AZABAN plugin, that is starting and stopping the jobs. So before it starts the Flink job, there is a piece of code that just finds, goes through S3 folders to find either the latest checkpoint or save point, and then takes that and passes that information as an argument to Flink, like, okay, because you can tell Flink to start from a checkpoint. So I don't know, this is something that I feel that it should be somehow be automatic, or some kind of like you could define that, hey, by the way, I want this, the default behavior of my Flink cluster to be such that, hey, it will try to start from the latest checkpoint. So then one thing that happened to us was that we sometimes have like a really low frequency partitions, and then some partitions or topics, low frequency Kafka topics, and then we have like super high frequency like ads impressions, ads requests. So we did some windowing on this and noticed that, hey, why doesn't our window close? So, and it was due to the fact that there were these idle partitions. Some partitions didn't get data for hours, but we still needed that data. So what we basically then work around with this problem that we actually added a functionality into our producer that was creating these kind of empty messages with correct event timestamp to kind of create this heartbeat message so every partition had data. So this way the window closed nicely, and we were able to, without a lot of changes, we were able to do the use case that we wanted to do. So, yeah. And then last is about how to initialize the state. So there have been many talks. There was one, I think it was Lyft's, and it was like the US Flink forward. So take a look at those. So those go into more detail how to do it and give some options. This is the one that we've been now using, so it might not apply to your use case. But we basically have two different streams. One is kind of this initialization stream, and then we have this like proper stream. And then in the initialization stream, you ensure that you use the same UID and state name, and init that state from a file. And you need to run this system in this file process continuously, because if you don't run, then Flink will just stop after it's read all the data, and you are unable to actually do the save point before the system finishes. So we basically run it so, and then we monitor the actual Flink job that, okay, when there is no new data coming in, then we are doing the save point, and then we are shutting down this initialization stream. And then you start your streaming job from a save point and start processing Kafka events from specific point of time. And how to do this starting from specific point of time from Kafka? Honestly, this was supposed to be my great finisher. And then we noticed that, oh hell, like starting from Flink 1.5 and Kafka 0.10, it's actually out of the box functionality. So you just ensure that you add the event timestamp in the Kafka message, and then you can use this Flink Kafka consumer set start from timestamp. So it's really handy, because we were actually running versions that didn't have this feature yet. So consider this as a retrospective. Okay, what did we actually do with the older versions? So this is a anatomy of a Kafka topic. So it's basically, well, what does this remind you of? It's basically a set of arrays, and they are basically ordered by time. So how does one search data from these arrays? We used binary search. So we were basically, well, you all know how binary search works, but we were basically reading, using binary search to read data from Kafka, like take one event and see from specific, okay, was this the right one, and then go like how binary search goes, and finally found a offset where timestamp was close enough, and then also parallelized it so that we would be able to do it really fast. So that was, I honestly was so disappointed that community actually fixed this, because I was like saying that, hey, this was great innovation. Damn. Anyway, so as a summary, Rovio makes great games and data is heavily used. Streaming is used to improve time to data, especially in the cases where automated decision making is being done. And for production use, you need some additional features on top of the vanilla Flink platform, especially around the operations of that system and state management. So that's all. Thank you.
Thank you, Henri. So I think we have just a few minutes for any questions. Oh, I guess I'm the only one with a mic. No, it's no problem. Okay.
Hi, thanks for the talk. I was wondering, how happy are you with using EMR? Because EMR comes with a lot of stuff that you don't actually need for running Flink, and you're paying extra for EMR. Have you thought about migrating away and going into Kubernetes or some kind of other orchestration?
Well, we haven't really thought about it. So maybe we've been kind of we've been relatively happy with the EMR, even though they have this problem of additional cost and everything. But in the end, our team is quite small, and it's an area that we haven't really been doing. So maybe that's an option in the future, but we haven't really investigated it yet.
Thank you.
Any more questions? All right, thank you very much for coming, and thank you, Henri.
Thank you.